me, Darcy, your tutor. I'm here to run you through the first of what will be many pre-recorded tutorials based around the different kind of content that we'll be covering in this subject, advanced computational design, or ACDC as the cool people like me are calling it. Tonight, I think it's it's 5 o'clock on a Saturday. I'll be running through just like a simple warm-up exercise for in Grasshopper and Rhino. The main environment that we'll be doing a lot of our explorations in. This one will be pretty easy. Like, you can follow along with it, you cannot follow along with it. Whatever you want to do. If you've got like 2 screens, maybe you can have me on one screen and your own Rhino workspace on the other. Today we'll be making a parametric ring for you to maybe you can use it to make your own if you want, or you can add to the design or subtract from it or whatever you want. But it's just what I found. It's just a really easy exercise to introduce you to the basics of the program, but also sort of we cover a lot of the basics of programming fundamentals, like dealing with inputs and outputs and some basic data structure, and that's all within Grasshopper. Hopefully we'd have a bit of fun with it, and it won't take too long. So before you really crack into it, I better crack into it because it's past 5 on a Saturday. And yeah, we'll see how we go. Alright, so taking the liberty of already opening Rhino. So let's open Grasshopper and get reacquainted. For those of you who don't know, you can either type it or you can click on this little Grasshopper button there. And I'm in the wrong window, I think. I want to be in this one. And there we go. So my Grasshopper is taking quite a while to load because I have quite a number of different plugins that I've amassed over the years for many different things. You guys might be the same. For those of you that are playing at home, plugins extend the capability of Grasshopper and allow us to do just about anything, whatever you're wanting to do. Let me open up this base file that I've got. Cool. It's a very simple file that allows me to turn the canvas on and off at the press of a button, but I just need to turn something off. I'll run you through what this is in class soon, but what I've done is turn that off. That's better. Cool. Alright, so what's happened is there's a little Visual Basic script here. Don't need to know what it is now, but what happens is when this component, which is from Firefly, picks up that I've pressed the F4 key, it sets the state of the output to true, and then this feeds itself into this script that changes the appearance of the Grasshopper canvas. And then when I press F4 again, it goes back to not viewable, whatever you call it. Back to just Grasshopper. So because I'm recording on one screen, I thought it'd be easy just to set it up so we can use both at the same time. So we're going to be, as I said before, going to be designing a ring. There's a few, if you were just in real life going to design a ring, what might we want to do? Maybe we would measure our finger first, or work out how big it is. And how can we do that? Well, our finger is usually circular, so why don't we drop a circle onto the Grasshopper canvas? Now, it's a sort of assumed knowledge that you guys know a bit of Grasshopper already, and from the survey I did of you guys, most of you have basic Grasshopper knowledge, so I'm not going to be going over things like this is the Grasshopper canvas, this is the ribbon, and that in much detail unless it's a specific thing. But again, ask me questions and post on the Piazza about any problems you may have, etc., etc. So anyway, I've dropped a circle component down, which is defined by a base, plane, and a radius. So why don't we just let's just construct a point like this is going to construct a point at 0, 0, 0. And let's go, we'll make a number slider go from, I don't know, make it go from 5 to 30.0. So again, that's going to make a number slider that has options to go all the way from 5 to 30, and that's 25 integers. But because I've picked 30.0, that's going to be 350 different options, because it'll be like 5.1, 5.2, 5.3, a little bit more accurate because we're measuring our finger, etc., etc. Cool. So pretty quick. We know that this is probably drawing a circle. Yeah, there it is. It's 5 mil radius, so 10 mil diameter. So why don't we have a look if it's worked? Yep. And there's our circle right there. Brilliant. Cool. So hang on though. We're going to be designing a ring, and it's kind of, this circle's currently pointing like up. We probably want to point it like across, maybe, just so we can model how to look like sitting on a finger and in the right position. So what I'm going to do is go drop an XZ plane down and put it between here and here. And our ring has sort of changed direction now, which is good. Now what we want to, I'm just going to turn that off so we can see a bit better. There we go. So we've got our basic ring dimension down. We can measure our finger and move it up or down. So a radius of 10 gives us like quite a big finger there. But oh well. So now we sort of need to create. This is only one edge of the ring. We need to create the other one. So I'm going to do that by essentially copying this circle over, and I'm going to do that by using move. So essentially, in Grasshopper, because in Rhino, if you draw that circle, you wanted to copy it over, you would type copy and then move it across. Doing it this way is essentially replicating that purpose, so replicating that workflow. So we want to move it. We look down at our little gimbal that's in the bottom. We've drawn it in the X and Z plane, so we're going to move it in the Y direction. And how wide do we want to make our ring? We'll drop a slider from, why don't we just copy this one and move that across? And there we go. We've started to create. Started to create the base form of our ring now, which is going to be pretty cool. So what do we have to do now? Okay, we're going to start, what we could do is we could loft between this curve and this curve and make sure, yeah, that should be fine. And we've done, you know, we've made a ring. We're finished, guys. Class dismiss. We made a very, very basic ring, but obviously we're going to sort of extend it a little bit more and show you a few tips and tricks along the way, just to deal with, you know, one, adding a bit of detail to this, and two, explaining some of the under the hood that goes on with some of the data operations that will be associated with that. So what we want to do now is add a bit of detail, and we're going to add a bit of detail by sort of playing with the kind of forms of these profile shapes a little bit. Let me just close the hood back up. I'm essentially going to drag this all the way over here, and we're going to sort of break this off into two streams for a little bit. We're going to deal with this internal one. Why don't we group that now? Oh no, it's not internal. Left group. I'll call it right. Left and right rings. So divide, like add some circles. Sorry, add some points to this circle. Currently it's on 5. Just dividing curve. Number of segments 10. Why don't we go? We'll go 2 to, don't know, 15. And put that in there. Awesome. And then what we're going to do is, we probably need a bit more. I'm going to rebuild this curve, but I'm going to add a little bit of waviness to it, a bit of undulation, just for aesthetic purposes. Whether or not that's a good or a bad designed ring, you tell me. So what we're going to do is maybe we'll move some of these points, I know, in and out to do that. So looking at our gimbal, we want to move them on the X axis. So let's try that now. We always come back and change it later on. Wrong one. On the X vector. Do this, and let's just copy this for now and have a look what's going on. So they're our original points, and we'll turn them off. These are our new ones, and you can see that I've done, you know, they start at 2, obviously they're moving 2 in the positive X, all the way up to 15. So I want to be able to move every single one of these points a different amount. So how many do we have? We have 7 points, okay. Why don't we could do this, we could copy this down, and then we could plug all these in, right? We could do this. Okay, and watch the magic begin. And see how you can see these points move. And then what I'm probably going to do is, let's just, so we can see it a little bit easier, polyline. Close. Cool, so there you can see our circle turning into a weird distorted blob. You can see how this is good because it gives me a lot of control, but I have to, you know, manage all these sliders, which isn't particularly nice. There's another way we can do this. It's called a gene pool. Contains a collection of genes, i.e. variables. So it's like a nice little container of these. And if I double click it, it gives us a bit more information. We have how many points do we have? We have 7 points. We have 8 points. 7 points. Good. 7 points. So change that to 7. Cool. Keep it at, we'll make it 1 decimal place. and we'll go minimum. So we'll go start in the negative direction. We're at -10, and then we'll go 10. Cool, and I go OK, and this changes straight away, and I'll plug that into there, and oh, it's back at 0, and see I can start to change this pretty easily. That's cool. And then what you can also do, good thing about gene pools is, if you just wanted to change it, there's the options to randomize 1, 10, or 100%, and that'll randomize the inputs, which is, oh, well, that's pretty cool. Yeah, we're gonna leave it on that one for now. Cool. And why don't we also, let's just turn that off. So I'm just going to hide this like this. It's going to make it into a nice little string like that, little group. And then I'm going to go Control C and Control V, bring that down, and we've got 2 of them now on the same, operating on the different circles. I randomize that one, randomize that one as well. Cool, here's our different ring shape. And why don't I bring that down there so we can see. Cool, so what I might do now is a bit of housekeeping. Bring that back up here. Now, turn you off, and then I'm going to just start a merge component. 1, 2. Oh, that should be it. Cool. So you can see our ring is, well, it's not so much a regular ring anymore. It's a little bit different. And why don't we just keep going until we get something kind of interesting looking. Now, I like part of this, but I don't like the fact that this point is there. So I'm going to come in. Which one do you reckon it is? I'm just going to, no, this one. I'm just going to unfurl that one like so. Which is fine. Which is fine for now. Cool. Alright, so now let's just pretend this will fit around our finger and not be completely bad. And turn these off. Cool. And get rid of that one. So we've got this lofted surface. That's good. Oh, let's do a bit of cleanup first. We will group that. Oh, I'm just going to go here and go add to group. Cool. Oh, I'm not going to do that. I'm going to ungroup it because it's going to be there we go. Oh no. Yeah, we'll keep it like that for now. And then we'll go like this one. Add to group. Well, maybe we won't do that at all. I'll just ungroup that. But anyway, this is, you kind of get the idea. There's one stream happening up here, and then one stream happening down here. And we've got our loft happening, and so now we want to add a little bit more some surface detailing to this outside ring. So what I'm going to do is we're going to be using Weaverbird. Now, I know like a lot of you are pretty familiar with Weaverbird, hopefully. Where is it? There it is, Weaverbird. Essentially, Weaverbird is one of these plugins for Grasshopper that it's big. It's great for dealing with meshes, creating meshes, smoothing meshes. And sort of creating primitive forms of meshes as well. which I guess like when you're if you're doing a lot of 3D printing and design for 3D printing, it can be very useful. And if you do it properly, you can get some pretty nice clean meshes out of it. So before we start to use some of these Weaverbird plugins, we have to prepare our geometry for meshing. So we've got to turn into a mesh. If I simply just go mesh like this and have a look, better turn that one off. You see that it's created, or it seems to have created a mesh that's got 114 vertices and 102 faces, which is fine. For most things, if you're going to render this piece of geometry later on, that's great. If you're going to 3D print it, well, it would have to have some thickness, but it would be fine as well. But I'm doing a good thing to teach you guys now, because we'll be learning it or using it later on. When we're dealing with something where where file size is a concern, let's just say we want to learn to model our meshes as minimally and as cleanly as possible. So let's see if we can model this mesh in a much more simpler way. Because essentially, like all these are is because this mesh has been made from a series of polylines, 2 polylines, and polylines are essentially collections of straight lines. If I turn back to straight sections as well, do that. Turn mesh off. So essentially, this has just been made from a series of squares. Quadrilaterals. They're not all exactly square. But when you go to mesh it, it adds a whole bunch of complexity into it. Because it wants to, Grasshopper wants to match the sort of surface as much as possible. But what we can do is there's a lovely component called simple mesh. Creates a mesh that represents a BREP, or in our case, an open poly surface, as simply as possible. So we'll put that mesh down there and have a look at what we've done here. We've got a mesh that's got 28 vertices and 7 faces. Before looking at it, we know that we've got, our polylines had 7 segments on them, and this is the mesh that we're getting. So my previous settings are set in Grasshopper to show all the curves on the meshes. So you can see the difference immediately. A face count of 84 versus a face count of 7, so it's a 12th. This will end up being essentially a 12th of the file size, which is great. So yeah, nice and clean. As I think, as Patrick Schumer, not Patrick Schumer, as Fabian Schurer, says, you always want to model with the least amount of information needed. We don't need all that complexity. This is enough for what we're doing. So why don't we just do something very scraggly, and we'll go up to transform, and what if we go picture frame? Yeah, let's do this and hide that. So what this is going to do is going to take our mesh that's 7 faces, and it's going to create a new mesh with a higher genus, so high faces, where each high face count, where each face has a new hole in the center, resembles a picture frame. So think about before we actually look at the result, can we think about what we might actually get? And I'm going to put a number in the distance, and inset type. That'll be fine. 0%. That'll be fine. And there we go. We've got. Maybe 5 is a bit much. I don't need to go more actually. 5, 35. Cool. There we go. We've got a picture frame. Would you look at that? Awesome. So we're going to have have this kind of weird little, well, it will become this weird little ring that's got, so a few speed holes in it. And, this ring, currently it's got a thickness of 0, like, these planes, sorry, these mesh spaces, they don't have a third dimension to them, so essentially can't be made at all. So, most of you in this class are probably architect students, and a lot of you have 3D printed before, and if you've tried to 3D print anything out of Grasshopper, you've had a mesh like this. This is probably the thing you've done, and what everyone does is uses Weaverbird's. Where is it? Weaverbird's mesh thicken. There it is. Mesh thicken. So this takes our mesh that is that was one face and offsets all those faces in, so extrudes it all in, and caps all those extrusions off. And that's done it by about 5. We probably want to do it by about, I don't know, we'll go 4. Cool. And we'll turn that off now because we don't really need it. Oh. There we are. So now our ring has somewhat of a thickness, which is just great. You can see there's some weird intersections happening down there. I don't really like that. So, well, the good thing about parametric design is, there we go, and come in, and come back to here, and there we go, and open it up a bit more. Great. Cool. So, yeah, this is looking okay. It's not not the greatest thing, but anyway, let's keep pushing this a bit further. So just to recap, and I'll just turn this one on. The only draw preview geometry for selected objects. Had our surface. It's all flat faces. Simple mesh. So one face. Picture frame. Offset all those. Thicken, which is great. You know what? Like, this ring looks alright, but I don't. It's not really the design I'm after. I'm after something that's got a little bit more detail in the face count here. Like, I don't want to have a million faces, but maybe like 2 or 3 wouldn't be bad. So in between our loft and our mesh, our simple mesh. No, actually, after we simple mesh it, we're just going to reintroduce a higher face count to our meshes, but do it in a much more controlled way. So we're gonna subdivide these faces, so not by a million like the way that Rhino did in here. Not a million, but you get what I mean. But let's smooth it off. Usually, okay. My go-to one is loop subdivision. Where'd it go? Oh, maybe because I've got that turned on, I won't like it. There we go. So, loop subdivision. There we go. You see it, what will it do? Okay, so it runs recursive subdivision, cool, described by Charles Loop, my favourite guy. Number of subdividing iterations for each face, cool. I think this is in preset set for the way it handles naked edges. But this is kind of cool for now. Leave it at 1, plug it in, and now we've got yeah, it's pretty cool. A bit more detail. Cool. So this is starting to look, a lot more. Well, I guess what you call organic-y, or that kind of parametric kind of vibe that I don't know you're about or you're not about. Why don't we push it a little bit further, and we'll do a one component Zaha Hadid on it, because all you guys love Zaha Hadid, right? What are we gonna do? We've read Cutmore Clark. Now we do 2 levels as well. What this is going to do is calculates type mesh based recursive subdivision. described by Edwin Cattrall and Jim Clark at their first 1978 paper. If you look into a bit of computational design theory, you'll find Edwin Cattrall at the forefront of a lot of computational graphics papers. He's very, very prolific in the area. He was even, I'm pretty sure, like a CEO of Disney for a while. Won prizes for them. Anyway, let's have a look what Mr. Cattrall's work has given us. As I said, a one-stop shop. Zaha. So what it'll do is start to smooth it out a bit more. If I smooth out those sharp edges, so if we sort of have a look, cancel, preview. So sharp edges. Smooth, and then plug. Yeah. So the more levels of subdivision we do for each face, the better it gets and the smoother it gets. Let's just custom preview in there as well. Oh, there we go. Oh, beautiful. Pinkering. Yeah, pinkering. Yeah, that's kind of cool. I'll show you how to change it anyway. Color swatch. Let's go for, I don't know, something a bit more like, ready pink maybe. Yeah, that's nice. Cool. Yeah. Okay. So, it's starting to look like it's very, very misshapen, but it's got the makings of a ring in there. And again, something like this, like if you were to use, digital fabrication, you've got a mesh, which is great if we want to 3D print it. Is there a way? Here we go. Is mesh closed? I think this is a pufferfish. A pufferfish component. It'll test if a mesh is closed. So it wants a mesh and it'll output whether it's closed or not. And let's have a look. If it is closed, it means all the seams have been sewed up. It is cool, and we could easily 3D print this if we wanted to. So let's have a look what sort of happened across the life of our script. With our ring in the background there. Oh no. So we started off with our input geometry being, these two circles. Our left circle and our right circle. Cool. We've then introduced a little bit of complexity to that by moving, dividing them and then introducing the ability to, move the different points, which is fine, I guess. Cool. And we have the ability to come and individually tailor this, which is very good. And if we make a mistake, we can iterate through it very, very easily. Cool. And then we can even come back here at the very start and make our ring larger or smaller or longer. Now there's let's go through and count them, right? There's this point is our intro point is static. We have one piece of data, we get one variable which is the ring finger number. We can edit how long or how wide, whatever you said the ring is, like that. So it's 1, 2, 3, 4 different bits of information that once we divide the curves, and then 5, 6. Well, it's actually 6 and 6. So it's between 10 and 20 bits of data. We can input points that we're having. And then, the mesh frame as well. We can control how big or small they are. So that's another one. We can thicken it as well. Now, interesting thing that we've just noticed. So see how it thickens it from the outside in? That's if we measure our finger to be 25, and then it comes and thickens, pushes it in 2.5 mil. We've just lost 2.5 and 2.5, so 5 mil on our ring dimension. So that's not good. Why don't we go? If we come in and go negative x, there's an expression there. It'll flip it like that. Cool. That's great. Awesome. And then the level of Catmull-Clark, doesn't like a certain amount. We'll go 3. That'll be really smooth. And still closed. Great. Cool. So what about, while this is a like a parametric design workflow where we've got a lot of different parameters. And some people may say, oh, like this is advanced, but it's not advanced parametric design, this is advanced computational design. And there's a lot of talk about what the actual difference between parametric design and computational design is. And, well, for the most part, who cares? It's if it isn't your job to describe it, why matter? But as we're all all young designers wanting to learn a bit more. My take on it is parametric design concerns itself with the ability to have all these different parameters and have them, have them controlling the problem as much as the designer wants. I would say, okay, all parametric design is computational design, but all computational design isn't parametric design. That works. With, I guess, a lot of these parametric design workflows, and again, most things that we'll be doing in Grasshopper, they involve having some inputs, like a point, basic geometry, and some variables, and then doing some stuff to them, and then getting like a result at the end. And that's sort of one workflow all the way through. With computational design, I guess, like more pure computational design, it's probably not about having these one-directional workflows, or acyclic as some people refer to them as, but being able to build maybe recursive things that go in, and that'll go in the context of this ring, like a workflow to make the holes in our perforations in the ring to keep moving or keep growing, such that it makes every bridge here the same distance, right? Like they'll be close already, but they won't be perfect. So what we could do is in a computational design workflow, or more computational design workflow, we can say, all right, keep growing these out, and then test if the distance after each mil, test the distance between all of these. If that's 2 mil, stop growing that one, and if that's 2 mil, stop growing that one. But if that one's not, keep growing it, etc., etc. So it's like this loop that it keeps going through, it is hard to do this in Grasshopper, but in vanilla Grasshopper, which is using components, which is where we've got to turn to plugins, like Anemone is one that does it, or you can start to. This is called like it's a problem of recursion, or it's the way you approach a problem, or you can start to code it as well, which is what we'll be doing this semester, a little bit of at least. And I guess another thing that would push more towards a computational design workflow is minimizing all these inputs. Because essentially, let's just say we're designing a ring and we've got maybe 30, 40 inputs already. And like that's great, like it allows us to design a ring very quick, very detailed, but is there a way we can get the computer to do it? So now we've got this ring down, I'm going to go through and look at ways we can start to push that back onto the computer as much as possible. So let's have a look. Let's just turn this back off. We probably need to keep that point at 0. Maybe our finger input, we'll go finger Finger measurement is good. Awesome. So we've got the ability to, let's just turn this back on, to do this as, you know, we can change that offset all the time, but maybe there's a way that we can link this offset amount to this. Why don't we go something like divided by 2? We'll do that. Oh, cool. So yeah, there we go. As we start to move it up, maybe we'll actually change it and go divided by 3. No, we're going to go the other way. 1.75. Cool. Now we've made it proportional to our finger measurement, which is great. I think I actually want to make it go 0.8. I still have a bit of width to it. Now, as our finger measurement goes up or down, that proportional relationship will continue. Cool. So let's have a look for some other ways we can start to bring. Oh, there we go. That's because we've implemented that. That's carried across. Yep. There we go. Cool. Well, we go 7 and 7. That's, you know, essentially you just copy that down. Awesome. Now, if there's a way we can replace these, because again, while it's good, again, we wanted to have that control, but now we want to delegate that to the computer. Why don't we? Because again, these numbers are actual measurements going from -10 to 10, and at the moment they reflect our static choice. But there's probably ways we can. There's another way we can do it. So, why don't we use random? Generate a list of pseudo-random numbers. And what do we have? A domain. Cool. So, -10 to 10. Great. Number of random values. Oh, this one here, 7. And a seed of random engine. So the way this works is this is essentially an algorithm to make random numbers, but it also needs a seed to sort of kick that randomness off. And so it'll always be like, no matter what the seed is, you always get the same random numbers. So if I just copy this up like that, boom, you're getting the same numbers coming out. That makes sense. So, but anyway, we've got some random numbers now. Let's plug them in, and let's have a look what it's done. Oh. Has it actually worked? Yep, there we go. We're getting some random numbers now. Great. So let's plug that into this one as well. Get rid of that. Oh, I forgot that it's the same random numbers each time. So what are we gonna do about that? We could just do something like this. I know what we can do. Copy that down. Boom. And then why don't we just plug our seed? Oh, there's our, what is it, and result of our division. And why don't we replace that other one up there? Like so, and I think now we have the ability to increase the randomness. Well, the amount of points that are generated. So we make it make it really small. We don't get a lot of faces generated. But when we start to increase that, we get more and more faces, which is cool. And that's controlling a lot of things at the moment, isn't it? So let's just bring that down here. In there. So there's one input. There's another. Cool. And then what else do we have? We have, oh, okay, that's our opening distance. Cool. Why don't we, it's 12 at the moment. Why don't we make that opening distance a factor of our extension? Maybe 22.5. If we go divided by 2, just easily. It's easy. Cool. Chuck that in there. And we got rid of another one. And thicken 2.7 mil. We could just do not change it at all, but because we're here, why don't we go? It'd always be our, I don't know, finger measurement. Why don't we do another division? That times that. Sorry, divided by that over that. 0.8. Maybe that relationship isn't good. Why don't we just go? That's divided by 0.8. Divided by make it 10, maybe 1.78 divided by 5. As a ratio, sort of sounds a bit better. 3.56, a little bit thick, but not really. Plug that in there. Cool. Yep. And then 6, 2.7. Why don't we use that same measurement up there? Cool. Awesome. And Catmull Clark, well, that's 3. Yeah, I'm going to delete that and just put that in there because it's the kind of smoothing I want. Those wall thicknesses are a little small, aren't they? Yeah. That'll do. Anyway. Okay, so now we've got something where we have no inputs here at all. No inputs here at all. We've got one input here. And we have one input here. And so as we start to vary it, really, I don't know if we need to. I think if we get it'd be cool to get rid of this measurement as well. You know what we can do. Okay, so we need to go. Maybe we need to. Well, we'll use a finger measurement, and we could just go. We could just round this number because it has to be like integers. But we could just go turn that into an integer because you can't divide. Well, you can divide something to 19.3, but 19.3 random numbers is a bit weird. How do we do that? And we need to plug that into there as well. That's a lot, isn't it? Oh, it's because it's divided 19 times. I know what we can do. We're going to replace these. Divide by length. This is a tool from paneling tools, which allows you to divide by an actual length. So there's our circle. What length do we want to do? Why don't we use our factor over here? 24, maybe, no. 19. Go divide by 4. Let's see what happens. That's 28. Ooh, that's probably a little more than I want. So why don't we go 2? 21. Let's have a look. This one and this one. Oh, something's happened. Oh no, done something wrong. Oh yeah, I just have to do that and do that. here, here, awesome. That one goes into here. Oh, 0 length. Okay. Something 0 length signature. Okay, that's fine. Create a line. Should be fine. Whoa, and this is what we're getting. Still getting a lot of numbers, a lot of points. Okay. Why don't we just go 8? Divided by 8 is 2.45. Okay. What about this one? Sorry, this is just me playing around. That's better. That's probably a bit easier. So now everything is conditional upon our finger measurement. Like take it or leave it. The good thing about this workflow is like it makes everything based on one measurement, and the more work you put into sort of tailoring your the relationships that are based on your original one, the better results you'll get. And as you just saw then, that's where you've got to put a bit more computational thinking in. And I'm sort of doing it all on the fly, but it can be very powerful, especially when you use if you use like random in a bit of a meaningful way, or if maybe you could make it go through a sine function to edit this number at all and to change that number, because I guess randomness for the sake of randomness isn't good design really, and I guess an example of that is sort of you see a lot of Voronoi kind of things that look like this around, and it's when they just sort of let the computer just go rampant, where we want to use the computer in a more controlled way, to sort of have more freedom. And in this case, like sure, we've got like this pattern that's based off the meshes and some random moves that have happened, but it's also all conditional on this one finger measurement, and depending on what you want to do, could be very useful. I don't want to keep drawing this out for more than it has to be. I'll be putting this script online for you to have a look at. And yeah, we'll leave it there for today, I think, guys. Please tell me if my videos are good. Tell me if they're bad. What you want to see in them. If they're too long, like I guess 53 minutes is a long time, please watch this on 1.5 speed. I highly suggest it. It's how you can get through this content a lot quicker. But it's 6 o'clock on Saturday night. I'm gonna go finish my beer and maybe make some dinner. So I'll see you digitally next week or in another video before then. See you guys. Cheers.